Good afternoon officially. Welcome to the machine learning class in the master program. My name is Thilo. We will spend half of the next semester together. The other half you will spend with Christoph there, and I will say more about us in a couple of slides or so. Topic of today. We will first talk thoroughly about the course itself. So we have some sort of expectation management. You know what you can expect, and I know what I can expect from you. And then we have an introduction to machine learning. Machine learning will probably not be new to you. You heard something. Maybe even some things, lots of things. Anyway, let's go over it to lay a foundation for about everything that follows. We will look into some things that you usually do not read about in blog posts, like computational learning theory. This is who knows. We will anyway look at it. So that's the plan for today. If it takes a little bit longer than the usual 90 minutes, I promise you this will be the only time this semester we will do it like that. And take a little bit of the lab time to finish the introduction completely. So, I would say we start with that and go through it. Logistics of the modules. What can we expect from each other? About me. As I said, I'm Thilo. I'm a professor at ZHW for computer science, focusing. I have a great pleasure and honor to be able to focus just on machine learning and artificial intelligence. I do mostly computer vision and speech processing projects with my research group using deep learning. So this is what I do in my research time. In teaching, I do this class and an artificial intelligence class in the bachelor. I have a part-time job since 3 weeks ago. I'm leading all the digitization initiatives at ZHW. Let's see how it works out, but I'm looking very much forward to it. So that you know a little bit about the guy who's talking to you. I like kite surfing. I used to have a mountain bike on that slide, but somehow I have no time for going biking anymore, so just kite surfing remains. I attend a church. I play stringed instruments, and every time I don't like to practice anymore, I switch to the next one, and then I play guitar for a while before I switch back to bass. And actually artificial intelligence and all the machine learning stuff is one of my hobbies. This is why it appears on the hobby slide as well. So I really like that stuff. I'm actually a computer scientist because I was fascinated by AI back in the end of 90s. I think I was the only 18-year-old who, as a birthday gift for his 18th birthday, got a textbook on artificial intelligence. And tried to read it. I didn't finish it because I realized I have to study before, so I studied computer science, and that brought me to a career that led me over studies in Gießen and in Marburg, and a doctorate using machine learning techniques to do voice recognition in movies, to a company near Stuttgart that did software development, and now I'm here and do research and teaching. And you may ask more and find out more during the semester. What's important, you can reach me anytime. Best is via email. If you have things related to the content of the class, or things related to research, or things related to careers, or things related to whatever, life in general and hobbies, whatever. Just ask. And we can make up for a coffee or even go to a lunch, or I want to use the time with you. What I usually learn in these classes is that I start standing here and thinking, I'm a smart guy and I can teach you something. And I find out after the semester there's a lot of smart guys in the room and I can learn something. So please give me the opportunity to learn something from you. I'm interested to find out more about you, at least a little bit. And I know it's an awkward setting, it's such a class. Not everybody can say a lot about himself, but I'd like to hear a couple of Voten, I don't know how to say that in English, a couple of sentences about why are you here, what do you want to learn, what's your passion with respect to machine learning, what are you interested in, and what do you don't want to do. Maybe you can hear a couple of things. Oh, I shouldn't have said that. So you're just here to pass a class. Oh boy, that's sad. Who wants to do theory? Who wants to learn something practical? Who wants to do some programming? Who wants to do some data analytics? Who wants to read research papers? I'm not so sure if we have that in the course, but that's very good. That's very good. You should do that in any case. We will have all of that actually to some extent. We will have some theory, because theory is very important. I actually sometimes struggle with the concept of separating theory and practice, because it's so intertwined. You cannot do the one without the other. So we need some theory, and especially in the beginning, we will lay some foundations, and it will take 2 to 3 weeks until we really see how it works out in practice. Coming to practice, we will do the labs with Python. I asked you in that homework thing you didn't see, that you please install Anaconda if you haven't, or any other Python distribution if you know what to do, but those who don't, just install Anaconda and you're fine on whatever operating system you are on. Use a Python 3-point-something version that is on there. We will use that and write Python scripts or Jupyter notebooks. Both things. Also probably okay. So this is what we will do in practice and then in theory. This all should be connected to research. You're doing a master probably because you're interested to some extent into seeing what can be drawn from the sphere of academia and research. And most of the things we talk about here in the lecture have some roots in the research we are doing with our groups. So if you're interested more in that aspect, just take the time, for example, in the lab and engage in discussions. We will actually have 90 minutes of, maybe we have that on the next slide. Yeah. We will have 90 minutes of lecture per week. That is basically us talking, that is Christoph and me that will do co-teaching. And we will have 2 times 45 minutes of lab afterwards. That's a little bit of an awkward setup in that program, but let's don't talk about it too much. You can use the whole 90 minutes because we actually give you programming assignments mostly, also tasks where you can think and draw with a pencil and a piece of paper, and they will usually take much longer than 45 minutes. That is for you to practice. I would say there's a linear relationship between how much time you put into that and how well you understand the topic. So you can use the whole 90 minutes to work on it. You can use up to 2 hours more at home to work on it, and it will profit you. Coming to self-study, the more time you invest in that kind of stuff, the better. Some things you have to understand, and you understand them better when you program them, and programming takes time. Some things you only understand if you have enough background knowledge, and for that you have to read something. We will give you quite some pointers to the literature, and we will ask you to read that. We will not check for that. You're in the master program, you can check for yourself. But use time where you have it to read some of the stuff. It's okay when you select a little bit, say, oh, my interests are in that direction, I read more here, and I skip the other one. But use a self-study time. Coming to the lectures, 90 minutes, 2 times 45 minutes. Shall we do a 5-minute break between? I will do it like that. I will stop when somebody tells me to stop. Sometimes I miss it. So maybe the guys and girls in the first row have to tell me. But I want to start again after 5 minutes. So if you go down and smoke and come back up, this usually takes 10 minutes. Try to keep it within 5 minutes or this. Good. Material. You have the material on Moodle. You have, I think, preliminary versions of all the slides, all the lab exercises, all the code and everything there already. What we will probably do is, the day before the lecture, go over our material and fix some typos and maybe have a very interesting example in mind that we will put in again. So within 1 or 2% of the material might change just before the lecture. It's not a problem. If you're a kind of guy that likes to download everything before and have it in a folder, that's fine. But you will only have the very final material after the lecture. Fine. We will try to do the video recordings, both of us. We will try to put it online as soon as possible, and we have created a website, this one, where you find all the material. You will still find everything on OLAT. Sorry, not OLAT, Moodle. You have the slides there and everything. You will find the slides additionally here, and you find here the links to all the videos. So if you want to look them up later to rehearse something or so, just go there. We will have the pleasure together for the first five days, so today and the next 4. Then we have Christoph for 6 times, and then I do the final 1 or 2 dates in the lecture. That's the idea how we split it. We had a chance to look over the material since summer, and I think it will be a very nice complement. I'm very much looking forward to that model of co-teaching. Maybe you want to quickly stand up and say hi, sir.
Yeah, okay. Probably I introduce myself shortly. My name is Christoph Wörsch. I'm a lecturer or a professor at the NTB. This is Fachhochschule Ostschweiz actually, at Books, you know. I'm a teacher for math, physics and machine learning. Yeah? And I'm a physicist, graded here at the ETH Zurich, and then actually came to machine learning by practice, really on the job. I worked for 11 years at Hilti Corporation, developing sensors looking into the ground material. So these were radar sensors and inductive sensors, and there we actually applied machine learning techniques to try to classify us in there, because it was important to get a good performance for these devices. That's how I got into this field actually. So really from practice, we had to do it, otherwise we could not stand it. And now it's a pleasure for me to teach you together with you. Thank you.
Exactly. So you can learn from 2 people. That's great. After you've learned, we somehow have to test it. That's the grading stuff here. We will have the usual 2 hours written exam. The regulations in that course are that you can bring 1 sheet of paper that you can write by hand on both sides and on the margins if you want. Why handwritten and why just 1 page? Because we want you to summarize the concepts you learn here. To break down 14 times 30 slides or so to 1 page of paper, and in that process of compressing stuff, that's actually from a paper in machine learning. You can read it up, Jürgen Schmidhuber, 1998, I think, learning by compression progress. By that you will learn quite a lot. And if our experience is when we do not give you some incentive to do so, you will not do and summarize everything in that way, and it will profit you if you do it. So summarize the stuff. You are allowed to bring that 1 sheet of paper, why handwritten, so that everybody does the summarization himself. I cannot check if that is your hand script. I do not want to, and I will not. But I want that it is not copied, that it is not digitally written and then printed, handwritten, because this has the highest correlation with you do it yourself. That's the only reason. The exam will, of course, be not in a manner where we ask lots of facts that we have to learn by heart. It's about understanding the stuff. It's about being able to do it. So even if you cannot earn points in the lab, I guarantee you, if you do the lab thoroughly, it will pay off in points in the exam. The labs are integral part of the amount we cover in the exam. So if you do the stuff, if you do the programming, you can have a good feeling that you know the stuff and that you can do it. Okay. And we will have the last lecture of the semester dedicated to asking questions, how will the exam look like, stuff like that. So if you have questions regarding that, you can collect them up to there or already ask them in the lab. That's all fine. But we will have a separate date just for that. So we want you to be well prepared. Basically, that's it here, I think. So, the course program officially asks you to split somehow into 2 groups and only 1 group be present at any lab. I think this is, we will do it that way. You can all be here for all the labs, except that doesn't work out for some reason, but it worked out the last semester, so I think it should be fine. And we will be here and be basically present. You work on your own, and we maybe may look what you do and get into discussions with you and are basically here so you can answer stuff about the lecture, about the lab, life, and so on. Questions regarding the stuff you already saw? Oh, that's a general rule. You can always interrupt and ask questions. Okay, seems to be pretty clear. Schedule. What are we going to do? So we're actually already here in the introductory lesson. We will, at any week, have a lecture that covers the 90 minutes of the lecture. We will have stuff that you can look into yourself in the practicum where we are here, and you can ask us. And we suggest you to do stuff, mostly reading, during self-study. These are suggestions. They're usually with respect to the content that we had in the lecture, so you can look up the stuff, sometimes do something with it, get a different perspective, use that at least a couple of times. I know that you're optimizing time and it's stressy in a master program, gives you much of free time. So we have a realistic view of that, but use it sometimes. Good, and here you see who is going to teach the respective week. One thing I want to make you aware of, there is 1 week where there is no lecture, that's the Easter week. So we basically just skip that and continue in the next week. And that leaves us, if everything works like we planned, with 1 week at the end where we have no content planned. We can give you lots of Christmas lecture kinds of things about cool stuff and machine learning if you want, but we can also use that if you have open questions regarding the exam and all that. So what we will do probably in this lecture 21st of May, I will ask you will you have questions next week regarding the exam? And if you have, we happily use that complete week for answering the questions and doing an FAQ-like session. But if you say, no, we haven't looked into it and we don't start learning until mid of June and whatever, we'd rather bring you some more content. So it's up to you to make up your mind what you want to ask there or what you want to do. Cool. Questions here? All good? Fine. Yeah. No, we will see that. What is the goal of the course? Of course, it's machine learning, that you learn something about machine learning, but still the goals could be different. So our goal is that you have a solid foundation and best practices in machine learning. That means we look into some stuff that might seem very, very basic to you and very, I'm not sure if I need that in my next project. But we think these are the foundations that need to be solid in order to then be able to look into other stuff yourself, for example, by reading papers and having the background knowledge to be able to understand that and follow it. And we want to give you the best practices, meaning the stuff you usually only know when you work on stuff for a couple of years. Like, you shouldn't do that, you should do this. And of course, there's a difference between solid foundations and best practices. Namely, a lot of material you could know, like lots of different algorithms. There are probably thousands of different machine learning algorithms out there. And what we won't do is cover a lot of them. We sacrifice covering every possible area of the algorithmic pottery in order to give you solid foundations and best practices. So the rationale behind that is, if you want to know about vanilla neural networks, not the deep learning stuff, but the old stuff, that can still be useful. We will not cover it here. But you will be able to look it up on Wikipedia or some textbook with a 2 hours investment of your time for yourself. And somebody else is not interested in neural networks, but some other fancy methodology can look it up in 2 hours. So we give you some algorithms, and we give you the foundation and best practices. That's the idea. So you can use it using Python, and that is our hope, that after the course and doing the lab exercises, you will be able, given a data set and a specific problem question, you're able to select the correct machine learning pipeline, the correct steps of what to do, the correct algorithm in order to solve the problem. If you can do that, this is the goal of the course. Yep. Regarding literature, I'm a little bit a literature freak. I really like books. I learn a lot from books and by reading them. I rather read a book than watching video lectures. And this is a collection of books that I really like about machine learning. This is the usual collection of books you will normally see if you look into the academic textbook category of stuff. So, for example, this is my favorite book. The Mitchell Machine Learning from 1997 is a pretty thin volume, just 300 something pages, maybe 400, a little dated from 1997. But it explains the things in a way that really give you a deep understanding of the stuff. It's quite mathematical without writing a lot of formulas. I like it a lot. Who's coming from the statistics area here? Some statisticians? So you might actually like the Introduction to Statistical Learning, and maybe that's a baby book for you, then you want to have the Elements of Statistical Learning. They're written by very well-respected statistics profs. PDFs are free on the web. Great books, introductory book. Basically, without a gap, this gives the material that this does not show. I verified that by one chapter on a specific algorithm to support vector machine. There are 20 pages on support vector machine in each book. The authors are more or less the same. If you stop reading on page 20 on the introductory book and then go to the elements book, it basically starts there with an overlap of 2 sentences, like no introduction here. So this is really if you already know something, but it's a very good reference, very good book, very thoroughly written, held in high respect by many people in the field. I also like the Witten and Frank data mining and machine learning book. This is one you can also give to your boss and say, hey, if you want to know what we're doing, read that. It can be read by business people, and it can be read by technical people. I like it quite a lot. Of course, there's a deep learning book you might know. And one book that I hadn't in the list originally, but that Christopher used quite a lot when I got it right from his slides.
Right. I put in actually Rashka's book. Actually, it's very practical because I also see that actually understanding really needs to practice. That's why I chose this one. It's quite a modern book, actually, like a few other books like that recently a little bit different from not really theoretical, but really applied.
It's probably the antithesis to Mitchell's book. Mitchell's book has no line of code in it. It's not very practical, but I find it a shower of warm rain to understand things. And I haven't read that, so I cannot comment on the text, but it also has code in it, and this is also very good. And it will be, some of the lectures are basic. Good. So you find stuff if you have more time you want to invest here. Educational objectives for today. So you should know the history and the breadth of machine learning. Why? I always think that knowing the history of something, where it comes from, who contributed, what are the different roots, helps to understand why things are done in a specific way today. So I want to give you that, even if it is not the stuff you need to code the next thing. And to set the first cornerstone of good solid foundation, we will look into what can be known about what is learnable. Who are the computer scientists in the room? Okay, as many as the statisticians. Later I have to find out what the other people are that didn't raise their hands so far. So computer scientists in their undergraduate studies usually talk a lot about what is computable. Are there things that are computable? Obviously, are there things that cannot be computed? Interesting question. We will talk about what is learnable and under what circumstances. Of course, this is something that has to do with machine learning. Good. And hopefully from there, you can tap into different areas of the literature yourself. And some of these areas we will cover in the course. Any overarching questions at that point regarding the whole module before we dive into today? All good? I suggest that we do the 5-minute break now rather than in a couple of minutes when we're in the topic, and then start and go through the material of today. Is that okay? And because it's the first day, let's say we start at quarter to